Howdy folks. I've got a whole video for you about fixing portable welders. 3 different models with 3 different problems. And I'm not sure how that happened exactly. I don't recall ever working on a portable welder before, but somehow I ended up with 3 of them here within just a few days of each other. So I kind of rolled it all together into a compilation video, and I think it's going to be pretty interesting. Before we get to that, I wanted to make a few announcements. We're getting very close to 100,000 subscribers. I think we're about 95,000 at the time that I'm recording this. So I wanted to do a few things to sort of celebrate that milestone, because it seems pretty significant. The first thing we're going to do is a question and answer video. I made a post in the community tab, and I will link to that in the description and possibly pin that in the top of the comments. If you have a question for me, doesn't matter what it is, personal, technical, rhetorical, go to the community tab and type it out as a reply to that post. I will go through, I don't know, sometime in the next few weeks and compile those questions, and I will do my best to answer them. At this time there's well over 100, but most of them are duplicates, so I think it's going to be, we'll try to make it manageable, let's put it that way. I don't want to make a 3-hour long video, but I will do my best to answer all of them. Second, we're going to do a giveaway. I have the prizes picked out, and hopefully it's also going to include some new merchandise. I kind of dabbled in that once before. It wasn't super successful, and then when the coronavirus came around, I just cut it off. I didn't want people to be buying things and not get them shipped within a timely, in a timely fashion. So I cut that all off, but we're kind of ready to try to do that again, maybe a little bit better this time. I've also got some other prizes picked out. I think you guys are going to like them. We just have to figure out how we're going to go about selecting the winners. I'm going to think on that. We've got a few weeks to figure it out. Looks like at our current trajectory we should hit 100,000 in maybe 3 or 4 weeks. So look forward to an announcement about that sometime in the near future. Also, something interesting happened to me recently. I was at an auction, kind of an estate sale type of a deal. Anyway, I bought, some stuff, bolt bins and some various taps, and they had a small flat full of metric taps, which I kind of wanted. I don't have a very good selection of metric taps. Anyway, they couldn't get a bid on them, and I kind of stopped paying attention, and they grouped them together with a bunch of other stuff and sold them off, and I missed the chance to buy them. It just so happened that the guy who bought that stuff was standing right next to me, so I asked him if he would be interested in selling just the taps to me privately, outside of the auction. That happens all the time. And he kind of looked at me and said, "Hey, Wes." And I did not recognize him. And he says, "You don't know me, but I know you from YouTube." And yeah, we kind of had a little chat. Turns out he's originally from this area. He lives, I believe, in Colorado now. He was in town for whatever reason, decided to come to the auction. And long story short, instead of selling me the taps, he offered to give them to me, kind of as a, I guess, contribution towards the YouTube channel. So that's pretty cool. And PJ, if you're watching, I really appreciate that. And I think that is the first time that anyone's ever recognized me outside, in public, just from the YouTube channel. I live in the middle of nowhere. I'm kind of a hermit, just not something that's ever happened to me before. So it was kind of cool and interesting, interesting interaction. So thanks again, PJ. I really appreciate it. Alright guys, I casually mentioned this little Miller Bobcat 225 portable welder in a previous video. It's here for some wiring repairs, and a lot of guys were asking about an elaboration on that, or if I could make a video about it. It's not that exciting. It does not warrant an entire video, so I'll just kind of throw you guys a little summary here. So the reason it came in here initially, there's a diode in the wiring harness here that runs to the engine, and it was broken. One of the legs is broken off and completely missing. It's kind of a hokey way they do it. The
diode just splices into the wires as they run through the harness. And the only purpose of that diode is to bypass the oil pressure switch. So the engine would still start and run, you just had to crank it long enough to build oil pressure before it would fire. So anyway, I wasn't 100% sure how to identify this diode, so I just bought some 10 amp rated rectifier diodes, and I think it's going to be fine. All it has to do is provide power to the fuel shutoff solenoid in the carburetor, and I think it pulls like 300 milliamps or something, so it's not a big deal. Sorry guys, I'm nursing a cold, so I'm a little extra nasally today. Here's the wiring diagram. The nice thing about Miller, unlike some other companies, they make all their owner's manuals available for free on their website, and they have pretty good wiring diagrams. So here's the diode right here that had the broken leg that we replaced. All it does is when that starter solenoid is activated, you have 12 volt power here going to the starter solenoid. It allows that power to come down here and turn on the fuel shutoff solenoid, which normally does not get power until the low oil pressure switch closes. So you would have to, without this diode, you'd have to crank it until this low oil pressure switch closes and then provides power to the fuel shutoff solenoid, allowing the engine to run. So this is kind of a little bypass. And it's kind of interesting, this engine must have CDI ignition, and there's no cutout on the ignition as far as I can tell. The only thing to shut the engine off is the fuel shutoff solenoid in the carburetor. Anyway, nothing too exciting. I did clean the carburetor. It runs okay. It's kind of cold-blooded. You got to choke it for quite a while before it's really happy. And it still flutters just a little bit at high RPM with no load, but I think if you put a little bit of a load on it, it would snap right out of that. The idle circuit doesn't work. It has a little servo motor here that's supposed to idle the carburetor down when you flip it to that idle position on the key. Anyway, that's it guys. Well, for whatever reason, it's raining portable welders here, so maybe we'll throw together a whole compilation video of fixing them. This is another Miller Trailblazer 251, belongs to the same guy as the last one. Pretty similar machine. It's a little bit newer, I think, and it has a Onan engine instead of a Kohler. And this one has a problem in the welding unit. He said he was just welding with it and it stopped. No output or low output. He sent it to an authorized Miller repair facility. They checked it and they found a short in the stator winding. So it's supposed to be this lead here, 73, is supposed to be shorted to ground somewhere. So we're going to check that real quick. He just wanted a second opinion about it before he kind of moves on. I guess the stator winding is not available from Miller. It's discontinued, and the cost to have it rewound, it exceeds the value of the welder. Now, before we get to that Miller, I've got a Lincoln Ranger 330 MPX. This one belongs to a different customer. It is a crank no start. It's a V-twin Kohler of some kind. I'm assuming it's a Command series. Kind of hard to see inside this enclosure, but it has no power to the fuel pump. There's a little electric fuel pump right here. There's the power leads right there. Well, I'll show you what it does. The control panel on this thing is insane. I have no idea why anyone would ever design a welder this way. It's got a little LCD screen here with 4 buttons and then a little iPod style, I don't know what you want to call it, scroll wheel or whatever. Anyway, when you turn the key on, sometimes the screen comes on, sometimes it comes on and flashes, sometimes it does nothing. Yeah, so there it came up. But it's just going to hang there. Yeah, so it just went out again. Anyway, I'm pretty sure that the control board that controls this little screen is bad. Imagine trying to use this thing. You're hot, you're sweaty, you got big thick gloves on, you're trying to navigate these goofy little buttons and turn this little knob, shading the thing so you can read the readout in the sunlight. It's just crazy. How is this any better than having, physical knobs and buttons you can push and turn? It boggles the mind. To take an industrial piece of equipment like this and turn it into an iPod, I do not get it. Well, here's the wiring diagram. This chopper control PC board, it seems to do everything. It even controls the electric fuel pump.
And then that LCD screen that we were seeing on the front of the machine, that's actually controlled by a CAN bus network. So you got CAN high, CAN low, and then must be a positive and a ground. One of them's probably a shield. Anyway, the stuff for the engine's over here. Looks like it gets power from the 12-volt battery through the key switch on pin 5 and in to this connector here, J2 pin 9. So we can check for power there. And then there's a couple of grounds. Looks like J1 pin 14. And I'm pretty sure there's also a ground on J2 pin 14. It's not shown on this diagram, but I can see it inside the cabinet. Then there's a heat sink ground here. I don't know how important that is. But yeah, we can check a couple of these things, but I'll bet you anything that this board is bad. Well, there's the back side of that control panel. So you got a connection here for your CAN bus, and I'm assuming power and ground. And then what? 6 wires for that little scroll wheel and the key switch. And there's the big circuit board right there. It's all potted. There's nothing we can do with that. Now, as far as powers and grounds, you guys can't even see, but up here, that's J2 connector, and I've checked pin 9 for power. It's good. Here's the J1 connector, and the wiring diagram very clearly says J1 pin 14 is supposed to be a ground. Well, there's pin 16, that black wire. If you go 2 back, you'll see that there is no wire in that connector at pin 14. So it's a typo in the wiring diagram because there actually is a ground on connector J2 pin 14, and I checked it and it's good. Well, just for giggles, we can check power on this little 4-pin connector to the LCD screen. I don't know if you guys will be able to see it or not, but yeah, it's got good power there. So I guess we can check the ground. If there's a ground, let's see. Alright, well, I don't want to go poking around in there with the test light if I don't know what they are, but we have power. I doubt highly that it has a problem with the ground, but I guess it could be. Well, that's cute. Well, all of a sudden it came to life. Max, buddy. I hate stuff like this. I hate intermittent problems. Well, let's try it again. See if it wants to play nice again. Yep, fuel pump's on. That's crazy. Wouldn't do that at all before. Okay, what are you gonna do? Well, I don't know what happened. Bad connection somewhere, I guess. I'm thinking maybe this Amphenol connector on the back of the LCD panel was the problem, but I don't know. I don't have any way to pinpoint that. It doesn't really matter because the machine's still under warranty. So he's going to take it down to the big city, to the authorized Lincoln Repair Center, and they'll give it a look over. Yeah, I don't know. I'll tell you this much, I would never want to own one of these machines. Computers can do a lot of cool things, and there's a lot of great applications for them, but running a portable welder is not one, at least not in my opinion. It's been about 4 hours since we tried it last. Let's see what it does now. There's the fuel pump. Yeah, see, I always don't think that's right. Flickers on and off like that. Yeah, there's no way that's correct. I think it'll start and run. Choke it a little bit. Alright guys, that's as far as we're going to go. Like I said before, it's under warranty, so we're going to let them take it down to the Lincoln Repair Center and they can try to make heads or tails of it. I really don't know, what the problem is, but it does not seem like it's working correctly. So, yep, on to the next one. Alright, let's jump back on this little miller, see if we can make heads or tails of it. I'll tell you what I know. It starts, it runs, and it has some output. If you hook up a device to the 110 volt receptacle there, like I had this little grinder, it'll run, but it only puts out about 85 volts AC, so it's a little bit low there. The 220 receptacle right there, it basically has no output, about 8 or 9 volts AC, something like that. And I think that'll make sense in a minute why that's happening. You guys may not be able to read this, but I'll paraphrase for you. Basically, the repair center says that they checked everything and they found a short in one of the stator windings on wire number 73, which is ground out, causing something to only get low voltage off the excitation field. Talked to Miller, confirmed this is the problem, which is rare. Cannot repair because the part is obsolete. Alright guys, we're going to try to walk through this. The autofocus she's having a hard time. Yeah, there it goes. Come on, come back. You can do it. There you go. Anyway, we'll try to muscle our way through it. I've got an actual service manual for this welder, and it has an excellent wiring diagram. It even has known good voltage and resistance values for a whole bunch of test points, so it's very comprehensive. Anyway, I'm going to try not to screw this up too badly, but the good news is there's a lot of really smart electrical people who watch this channel, and if I get this wrong, they will correct me down in the comment box. So if something doesn't seem quite right to you, just go ahead and scroll down and your questions, I'm sure, will be answered. Anyway, I think we're going to find our problem somewhere in this region right here. So this is a rotating field alternator or generator. So normally, like in a starter motor or something, we would expect the field to be fixed, and then the rotor or armature rotates inside. This is kind of backwards of that. So the two-pole field actually rotates inside of the three-pole winding. So this is a three-phase AC, alternator or generator, whatever you want to call it. And here's your rectifier right here to convert the three-phase output into DC power. So the exciter field winding is going to actually provide power to the main field winding. There are no permanent magnets inside this alternator, so you have to have power, DC power, in order to create the magnetism that allows it to generate electricity. So the exciter field actually has a couple of different things going on. So this top portion up here, I believe, is what creates the 110 volt that we're seeing on those receptacles in the front. And then there's a section here that basically provides power to the excitation coil itself. So it's kind of weird. The excitation section of the generator powers the field of the main part of the generator, but it also has to be powered itself. So in order to do that, what they do is it actually takes 12-volt power from the battery through the key switch, through a couple of diodes, and into the slip rings, and that actually kind of kick-starts the excitation field. And then as soon as it's rotating, it creates its own, it creates some current through this little coil right here, and that basically powers itself. So this section right here provides power to these coils in the field in order to kind of make this thing work. And then I think this winding right here, if I'm reading it correctly, is what provides the excitation power for the main field over here.
Need to jump in here real quick. I believe my explanation of the generator section is more or less correct, but what I forgot to tell you is that this coil does create the excitation power for the main field, but it doesn't do it directly. It takes the power, rectifies it to DC, sends it through this circuit board over here. That's a field control board, and the field control board does just what it says. It controls the power to the main field, and that is how you actually control the output of the welder. So the constant current or constant voltage output from the main field is regulated by that circuit board.
So the note that we read said wire number 73 was shorted to ground, but that's over here on the main windings. That's the main output of the generator. That's not the exciter or excitation portion. So I'm kind of thinking maybe it's a typo and that he's actually talking about wire number 43. So if this one is shorted to ground, that means that, well, let's back up a little bit. We know we have some power coming out of the 110 volt receptacle on the front of the machine. So it seems like this section of the generator is working. It's doing something. So we can probably assume that we're getting some power here, and it's generating electricity here. The thing is, I don't think it's spitting out the correct voltage here, which is not powering up the main field, and it's basically shutting off the main portion of the alternator or generator. So I think what we need to do is do a resistance measurement from 43 to 44, and the thing's telling me it should be less than 1 ohm or around 1 ohm. And then I guess we could fire it up and do a voltage output, and we could also check both sides to ground. I think that must be a typo. Alright, so we only got 13 volts across the exciter field. Should be 50 volts DC. And if I measure the resistance across that exciter field, it's supposed to be 12.3 ohms, and I'm getting 16.5. So that's the only thing I've found so far that's out of spec. Alright folks, I'm back on this Miller welder. It's the following day. Something just doesn't add up about the little note that we got from the repair center. I'm not finding anything that's shorted to ground. I'm not really finding any problems. Anyway, the service manual has a really good troubleshooting section, and it has a whole list of things to check if you have low weld output. So I went through and tested most of these things I could test. So the amperage / voltage control, the little potentiometer, that seems to be working fine. Capacitor 1 is good. Engine speed and air cleaner, those are fine. And then I went to check the SR3, the rectifier that takes the exciter voltage and turns it into DC for the magnets. Anyway, that's it right there. And I wanted to unhook the wires so I could check each of the diodes individually. And when I did that, this terminal pulled out of the diode, broke right off. So I don't know if it was broken before or if I did that just trying to take it apart.
Anyway, I chipped through the potting on the inside here, the epoxy, and I tried to solder that back together. So we're going to hook it back up and see if it works. Obviously it has to be replaced, but just for testing purposes I want to put it back together and see what's going to happen. Everything else seems to be fine as far as that checklist goes. So what's going on, or what I think is happening, is this circuit right here isn't really doing anything. The only voltage that's making it into the exciter field is the 12 to 14 volts that's coming from the battery slash the engine alternator coming through these diodes. So this section right here doesn't seem to be working at all. And I checked between 28 and 29, across the winding here, it's less than 1 ohm, and it's not shorted to ground, so I don't know what's going on. The fuse is also good. So yeah, anyway, put that back together and we'll see what happens. Yeah, so as expected, the rectifier was not the problem. So let's move on to something else. Alright folks, instead of banging my head against the wall, I decided to call Miller and talk to their technical support people. They were very helpful, and they gave me a couple of things to try. So the first thing he wanted me to do was check this diode right here, the D1 or D2 diode. That basically makes a one-way path from the battery up to the excitation winding. And what he said can happen is if this D2 diode shorts, so it basically becomes a short circuit, a closed path in both directions, that the battery has more capacity than the field, and it will actually start sending all the current this direction and rob the field winding of the power that it needs. I checked that, it's good, no problems there. So the next thing he suggested was take and disconnect 43 and 44 from this SR2, this rectifier unit. And I did that. I'll show you guys. The SR3 is right here. So I disconnected the wires. And what that essentially does is it shuts off the excitation control board, and it more or less disables the welding output and just runs the excitation field. And when I did that, the 110 volt came back and it works perfectly. So my little grinder over there, just like plugging it into the wall. Anyway, I called him back because I didn't know what that meant. And so he had me disconnect the other two wires from the rectifier and basically rule out the rectifier being shorted. I did that, and the 110 volt was still good. So that brings us down to this control board being bad, the excitation control board. This is only used for the welding output. The excitation field, I guess, is self-regulating. Anyway, looking around at the board, I don't really see any problems. It's conformally coated, everything's nice and clean, but attached to that circuit board is this big honking electrolytic capacitor. And you see it looks like it's been through hell. But there's plenty of insulation inside these things. That doesn't really make any difference, but I did some testing on this capacitor. I think it's bad. So I'll walk you through the test real quick. I've got the multimeter set up to test capacitance, and it reads nothing, OL. If I check this other capacitor down here, see it's reading 240 something microfarads, so that one's right on the money. This one, nothing. So if I switch this over to ohms, oh, that's continuity. Either way, it's a bad sign. Yeah, 0.1 ohms across an electrolytic capacitor. I think we've got a problem. 0.1 ohms. Now compare it, this other capacitor is a little bit smaller, but
show you the difference. Yeah, 1.5 mega ohms. Go the other way. Yeah, so that's a problem. I wonder if we could just take that capacitor out and try it briefly. I wonder if that would hurt anything. You know, it's a filter capacitor, so it shouldn't matter. That's a DC circuit. All it's doing is cleaning up the noise out of that rectifier. I don't know. I don't want to mess up this circuit board because this board does not exist. It's obsolete. This machine is from the mid-90s, 25 years old, and yeah, there's no parts available. The stator windings aren't available, and yeah, that circuit board not available. Let me think about it. Well, I don't know. I was going to try to MacGyver together a bunch of smaller electrolytic capacitors in parallel and somehow splice that in with that big one goes. I don't think I have the right combination. Let's just try it real quick without it being there. See what happens. Yeehaw! I think that's it. We got our 2 LEDs on, and the grinder works perfectly. All right, folks, that's the call. Needs a capacitor. I'm not an expert about aesthetics or marketing or anything, but I was playing around with the grip mat, and I just colored in the logo with a Sharpie marker. I feel like it looks so much better. I wonder if they could do that in the manufacturing process. I suppose it would have to be like an overmold or something. Probably triple the cost of this thing, but I think it looks sweet. Anyway, I got sidetracked. This is the part that we think is bad. There's a new one. They are both 1200 microfarad capacitors. Fairly similar tolerance range. This one's from -10 to +50%. This one's -20 to +20. The new one has a little bit higher voltage rating. That shouldn't hurt anything. It's the same diameter, I think, or pretty close, but much shorter. And you know, that's pretty much the standard deal with electronic stuff that I run into. It's always smaller the newer it is. And then I also got a new rectifier because I don't trust the solder and super glue job that I did on the other one. And you can't really solder these things. That the heat sink just sucks all the heat right out of the soldering iron. So and we have to use some of this thermal transfer paste on the back side here. Looks like the connections are the same. We'll have to fix that one. Yeah, I don't like that one too much. Let's see. Hi, bub. How we doing, buddy? Yeah. There we go. That's better. So the board is marked positive on this lead. Won't get that confused. Let's see. I think it might be better like this. So we're only going to be able to use one of these clips, but I don't think that'll hurt anything. Should hold it just fine.
I've got some leads. Little test piece here. Let's see if she welds. That is awesome. Well, there you go, folks. It welds. I don't know what else to say about it. That was pretty cool. It's very satisfying to fix something that's right at the edge of your abilities, or if I'm being honest, a little bit beyond it. And if you don't understand all the electrical jargon, fields and stators and excitation and yada, 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 don't feel bad. I barely understand it myself, but we were able to get through it. Now, why the Miller Sanctioned Repair Shop made a call on the stator winding, I do not know. Possibly it still has a problem with the stator winding, and it only shows up with a megger, a mega ohm meter, which measures the resistance of the stator at a very high voltage. I don't have a megger, so I can't test it, but it seems to have weld output, so I'm happy with it. I'm going to send it back to the owner, let him give it a shakedown. The best way to test it would be to hook it up to a load bank and really, load it down, but I don't have access to that, so a functional test is the best we're going to do. I guess what I'm getting at is we may find out that it has more problems, but for right now I'm calling this a win, and it feels pretty good. So I hope you guys enjoyed that, and I will see you back here for the next video.